Hi everyone. Thank you very much for joining today. We're looking forward to hosting our second in a series of Spark 3.3 webinars. Today, we're going to be looking specifically at supercharging Spark, some of the performance upgrades that are now unlocked with Spark 3.3 on Qbol. Nagesh is going to be hosting this call, and he is a solution architect, one of our senior solution architects, and he is going to share some of his expertise on Spark. So without any more ado, I'm going to pass you over to Nagesh, and we're going to get started.
Thanks, Matt. Thanks for the intro. Hi, good morning, good evening, and good afternoon, wherever you're based out of. Yeah. Thanks everybody for joining in today. As Matt just spoke about, we will talk about performance features, mostly performance and features that have been introduced in Spark, specifically Spark 3.3. Yeah. I'll just give a couple of seconds for everybody to join in, and then we'll get started. Okay, so let's get started. Hopefully everybody joined in. Okay, so here we go. Okay, so what we will, we'll start with basically what are the major performance enhancements, and we will dive into a couple of things. One is Bloom filter joins, the query execution speedups that has been built in. Then we will move on to basically advanced data handling, which have been introduced in Spark 3.3, specifically the complex data types in Parquet and Pandas API. Pandas API. Then as we kind of go through all these features, we'll talk about where these improvements, basically performance as well as other aspects, where those actually help in your real-time use cases. Now, before we get started, I just wanted to give a quick fact check about Qbol. Fast facts about Qbol, though. One of the things that Qbol, it started pretty early, that is 2011, yeah, when native cloud or native kind of big data as a service was pretty new as such. So basically Qbol is an open data platform, that is one, but again, it is native to cloud. Yeah, that's how it is being built. That's basically the DNA. Our founders were basically from open source communities. They were kind of founders of Apache Hive, which was the de facto data warehousing in the early days of big data and ecosystem. Yeah? So it's cloud native and it's open source data platform per se. And of course, as we see a quick demo, that's more self-service enabled so that anybody in the enterprise can get onto the platform. Market adoption, we have a very broad customer base from different domains, verticals, basically manufacturing, pharmaceutical, financial, IT, basically pretty diverse industries. And of course, location, we are based out around the world. Our customer first, this is one of the things that based on which we are able to kind of gain many customers. We have saved more than 600 million and the number keeps growing cumulatively from 2011. This is basically because of the patented technologies of Qbol and other aspects like workload aware auto scaling, the usage of better spot instances, which makes the which makes a lot of cost savings, and that's ultimately helps the customers. True and tested, we are processing more than exabyte of data every month, yeah, and it's, as I said, this is something which is growing. So that's a test statement that how Kibol is helping customers in processing their data. Then global presence, since as I said that, okay, there are large customers who are using Kibol 24/7. We have a support ecosystem which is based out of spread across the world, and which can support 24/7. And definitely, everybody on the call, you should go ahead and try out Kibol. It's free. The initial trial, you can simply log in and connect to your AWS or other ecosystem cloud platform, and you should be off within a few minutes. And definitely, since we are in open source and cutting edge technology space, we have a very good tech team with a lot of data experience. Now, I spoke about this already, but I want to kind of touch base on what are the personas as basically who in an enterprise can use Kibol per se. Yeah? So in an enterprise, we will find various personas, data engineers, specifically the developers of ETL pipelines or other aspects. So the data engineers, data scientists, the model creators, or algorithm creators, basically data scientists, business executives who are more interested in their dashboards and other aspects of those, and then data analysts who are kind of who are hands-on, but hands-on more on a SQL kind of thing, assume. So they can get onto Kibol. So the advantage is basically all Kibol can support almost every persona in an organization, and at the same time, it caters to a self-service ecosystem or a platform, so that data becomes democratized across the organization. And anybody who has got as a SQL, or let's say a Scala or Python, anybody can come onto the platform and use the Kibol platform with the data which is stored in the anywhere, literally in a data warehouse or an S3 bucket. Now moving on. Now, what are the advantages? Spark is available, correct? Is available on this platform, but what are the advantages of Spark being available on Kibol per se, correct? So I already spoke about that in the first slide when I was introducing Kibol, but of course it has got unmatched performance, making sure that the processing bottlenecks are not there, and for faster analytics. On top of Spark, Kibol does provide its own features, how it instantiates a node, how it reads the data from S3 or any other data source for that matter. So it has got some inbuilt performance which will help you in terms of faster analytics and unblock your data processing. If enhanced efficiency is one of the other things as I spoke about, because we have helped customers reduce a lot of their operational cost. And how we do that, there are two. One is basically the features that Kibol has, the workload aware auto scaling, the better usage of spot instances and other aspects. But on top of that, since this is a self-service and a managed ecosystem, the number of resources that are required to manage Kibol per se is pretty low. So the overhead or the maintenance cost, running maintenance cost is pretty low with Kibol. And since we are cloud native, scalability comes as inbuilt out by default per se, correct? Since you can scale with the number of nodes, or basically the memory required, the CPU required, or other specs, because you are on cloud. Yeah, that you should be able to kind of grow seamlessly without sacrificing the performance of your applications. So those are a couple of advantages when you are using Spark on Kibol, but there are many more. Now, since we are talking about the performance features of Spark, yeah, so we'll cover those. Okay, so a couple of things that we see is, and first of them is okay. Before I get into these particular points, there are many features. Okay, if you go on to Spark release 3.3.0, you will get all the release data points basically, and you will see many data points. What we are trying to cover is basically the high level or the important performance breakthrough and features, basically 6 of them to be frank. And as I said, you can anytime visit Spark release 3.0 and you'll get a bunch of them, the whole list basically. Yeah. Now let's talk about Bloom filter joins. Yeah. Now, when we talk about Spark or when we talk about big data, correct? Any of these cases, joins are pretty hard nut to crack. It's because there is a lot of shuffle involved, because since we are working in a distributed environment, there's a lot of shuffle involved. There are a lot of data movement that happens across the nodes, and things slow down. Yeah. Now, what with Bloom filters, the performance improvement that's seen with the TPC DS is 10x. Yeah, I'll talk about that in a bit more detail. I'll just cover the high level here. And as I said, it reduces the data shuffle by and in turn making sure that your query is executed fast and efficiently. Then there are a lot of query execution enhancements that has been done, and one of them is full outer sort join, which sees 20 to 30% speed up. Shuffle has join benefits almost like 20%. Yeah. Then enhanced data handling. There were a couple of things where the data handling was not efficient in the earlier versions of Spark, specifically in the Parquets and other aspects. So that has been improved a lot. And Pandas API also, where the data scanning and other aspects have improved, which have seen a considerable performance improvement. Now, as I said, we will dig a bit deeper into what Bloom filter joins are. Basically, if you see, Bloom filters are probabilistic data structure for data structure for set of membership testing. Correct? It makes sure that it checks that if a particular key is available in the larger data set or not. I will talk about that and how it works. And as I said, it reduces the data shuffling. Now, how it works? Basically, it creates the cache keys on the smaller data sets of the join. So join will always have 2 data sets, and this will work on something like a smaller data set and a larger data set. Yeah, 2 different data sets, and the keys are created on the smaller data sets. What it does is it filters out the keys in the larger data sets. Make sure that the keys which are not available in the smaller are removed in the larger data set. What it does in turn is basically it reduces the number, it removes the rows which are not required, because basically you will not get any join. Yeah. So the data on which the join will be executed, the large data set, correct? That is kind of reduced considerably. So this gives you a big advantage when you are running it over a large data set. And since it is probabilistic, you will have a couple of configuration parameters that we will talk about in a second. What are the key benefits? I think we have spoken numerous times, but again, network data shuffling and query performance and speed. What are the configuration parameters? These are something which will impact your how fast the filter can be, correct? What is the maximum items? That is the number of items which can be filtered, the maximum bits, basically maximum bits for filter, and then creation side threshold. What is the maximum threshold? Making sure that when a Bloom filter can be applied. So all these will make sure that Bloom filters is better optimized for the use cases. What are the best practices? All the above 3 parameters are something which can be tuned and make sure that it can be applied in the best possible way. And of course, based on the 3, you will have balance between the efficiency and the memory, basically. Now, that being said, I think this is what Bloom filters is. As I said, it's more about filtering out the data, the keys which are not available in the smaller data set, and make sure the large data set is reduced in size so that the performance is improved. The second is basically query execution enhancements, and a couple of points in this, right? Dynamic plan optimization. So one of the things is adaptive query execution. So dynamic plan optimization based on the runtime data. So it's not something which is planned beforehand, let's say, but it is something that as per the data, it kind of adapts itself. for optimal execution. Then what are the key features, correct? There's dynamic partition pruning, which reduces the shuffle. Again, by pruning unnecessary partitions, it will reduce them, the partitions which are not required. And then coalescing, correct? It's something which is again important, because when you get the output data post shuffle, correct, you might have a lot of partitions, but if you can coalesce them, get into one, the number of tasks will get reduced, as well as the data which is transferred will be better, because you can compress them, or you can use any other mechanism to kind of make sure the data transfer is much better. So coalescing helps over there. Then optimizing sort merge joins, and since it is AQE, since it adapts, it will make sure that it can use broadcast join wherever it is possible, because broadcast join is much faster, much faster than a normal simple join. What are the benefits? Again, it improves the query performances, lower the resource consumption, and basically improves the stability and reliability. Now, how to enable it, correct? It's a simple one with just a parameter setting that's saying that, okay, SQL spark.sql.adaptive .enable is set to true. If it is more on CLI based, or you can use, if it is PySpark or Scala, you can use configuration to do that. And again, use cases and impact, basically it's more where the data intensive ad hoc queries, okay, where you want the responses to be much faster. And definitely in the large scale workloads where you are dealing with terabytes and petabytes of the data, it will help you. Now, an enhanced data. So the earlier two, we spoke about more on how performance can be improved. This is more about how the data handling, and of course, this impacts in your overall performance as well. But now, Spark with Spark 3.3, there is a couple of improvements in terms of what type of different file formats are used, specifically like Hive buckets. There are a lot of enhancements on those, but on top of that, there are enhanced Spark-in or ORC file reading and writing performance, which has been added to Spark 3.3. We spoke about this data partitioning in AQE, basically dynamic partition and tuning for more efficient data processing and reduce I/O, and basically custom and adaptive partitioning strategies to optimize query performances. Complex data types, earlier in Parquet, with the complex data types like maps, arrays, and structs were not that efficient. Now it has improved it. Enhanced UDF. Now in UDF also you can add better manipulation for the complex, because there are a lot of user-defined functions, a lot of functions which are kind of added now in the latest one. So I will talk about that in a couple of seconds. Then data lake integration. There are deeper data lake integrations. There are a lot more data sources which are added. Better support for data lake and asset transactions and version history, so which will enable you to kind of make sure that your data lake and your querying capacity with Spark and Spark 3.3 improves. Yeah, and there are a lot of performance tuning and debugging that has been introduced. New tools which have been added in terms for debugging and Spark tuning, basically. One of them is basically enhanced metrics. Basically, there are more metrics for Spark UI and execution log, which helps you kind of tune the job as. Now, we spoke about these are the earlier features were more to do with performance, but we'll talk about what are the new features which have been added to Spark. A couple of them have been related to the ANSI compliance. Yeah, the compliance. And what it does is basically when you are ANSI compliance or ANSI SQL compliance, you can migrate from a traditional data warehouse. The SQL queries and other aspects can simply migrate to your data lake and Spark running on it. Okay? The migration becomes much easier. I'll talk about those features in the next few slides, but that's one. The second is a lot of built-in functions that are added in terms of regression, statistical processing, and other aspects. And then the last one is it has enhanced API coverage for the pandas. Now, pandas is something which is used aggressively, or let's say used more by data scientists and others to get things done quickly, because there are a lot of libraries which are available, and data scientists are more used to those kind of pandas libraries. Yeah, now those have been kind of used more effectively in with PySpark, and this will kind of definitely help in data manipulation and analysis more powerful. Now, as I said, we will talk more on ANSI compliance and migration potential, correct? So what are those? Basically, there are a couple of them. One of them is basically ANSI interval data types. Yeah, so basically, what used to happen earlier was the interval data type was basically it was broken. Yeah, one is it couldn't be persisted, and second is basically it is not comparable. And why it was not comparable? Because it always crosses the month day in the line, correct? So that is, so basically I'll give you an example where it says that, okay, 1 month 1 day is equal to 1 month 1 day. So when you start comparing that, that was becoming a bit dicey. Yeah? And why was that? Because not all the months will have basically same number of days. Yeah, some of the months might have 29, 30, 31. So because of that, the comparison was not always possible. Now, because of that, the changes were proposed, and it was picked up with Spark 27790. And with that, now we have enhanced capability of reading and writing the interval values to and from the tables. And then there are other, like now you can do the operations, correct? I just gave you an example. Comparison was one. You can add the other functions like date addition and date arithmetic, basically, correct? Those aggregation and comparisons are much easier with these interval changes. Now, there are a couple of implicit casting that has been added into ANSI mode again. What are those? Basically, you can convert it from, let's say, a simple number to timestamp and vice versa, correct? Earlier, you have to do a lot of dance to make sure that the conversion happens. But now there's something which come as built in. The others are basically try functions. Yeah, try function are amazing. Yeah, it's pretty cool. It makes sure that you can write stuff and write stuff which can go wrong, but at the same time, it makes sure that there are safety rules which are built in and make sure that the query doesn't fall always, and it becomes more fault tolerant. And what are the benefits of all these, right? One is basically it improves your data processing, and at the same time, it makes sure that you have safety and integrity of the data. And as I was talking about, with all these try capabilities and others, it improves a lot of, you can write better data querying and manipulation, but at the same time, the queries becomes much more fault tolerant. As I was talking about earlier also, there are a lot of built-in functions that have come in with Spark 3.3. A couple of them most of them, okay, are related to, let's say, we spoke about the earlier use cases, correct, where when you are doing SQL functions, but otherwise you have something like regex extract all. This is one of the function. Datetime functions we spoke about a couple of them, new functions. Then array functions are there added, map functions are added. All these functions make sure that you have enhanced data manipulation capabilities. Now, the use cases again, as I said, I think we were talking about in a few slides back that all these functions help in creating new functionalities, new UDFs, and other aspects which are not something which are available built in, correct? So you can do that, reducing the need for custom UDFs, and particularly specifically for the data science and other BI tools where these built-in functions you can use simply these built-in functions rather than writing your own UDFs. Okay, and if you want, you can definitely all these built-in functions will make sure that you can write better UDFs. And then this is a simple example, yeah, where I extract all, and this you couldn't write it earlier. Now you can actually have this simple string. You want to extract all the numbers out of it. Examples from Dual, this is simply extract all the number values from a string. So this is a simple function. Earlier there was a lot of, probably you have to write a decent Python and PySpark code. Now it is with the simple functions that you can do. And there are a couple of more, as I said, from date functions, array functions, and others which you can use. Okay, and I was talking about from a data scientist perspective, correct? How it helps. So one of the things is making sure that enhanced API coverage for pandas, and as I said, pandas is something which is used extensively, and it is loved by data scientists. So there are a lot of coverage for the pandas APIs now. And a couple of these are key enhancements are leverage pandas. That's one. Improve performance, optimization of pandas UDF, and type conversion operations enhancing the execution and speed. Correct. And again, what it helps is in greater flexibilities, making sure that there's increased support, and as you have increased support, you can do a better complex and data manipulations. Now, what are these? Okay, so one of them is basically example usage. You can see apply in pandas. Apply in pandas as these are the functions if you are using pandas. And it's a simple function to add a new column. Okay, and when you are adding a new column, multiply by 10. So it's rather than using all those juggling that we used to do with data frames, is a simple pandas, and then you can do this. There's one more feature that I have not added is basically the okay. So I wanted to talk about one more feature. Okay, so I'll just go back to Spark functions. Okay. Here. Okay, so the basically data handling, correct? So one of the things that has been introduced is this very important feature that has been introduced is vectorized Sparking. And earlier what used to happen is all these data types, correct? The data types which are maps, arrays, and structs, correct? These were not vectorized, and when you have vectorized, it doesn't read row by row. Now with this Spark 3.3, what has happened is these complex data types, that is map, arrays, and struct, these have become more, these have been become vectorized. So the reading is much faster. Yeah, you can see improvements, which is like 2x, 10x improvement in terms of reading these complex data types. Okay, going back. Okay. We covered pretty much all the 6 features that we started with. Now, talking about scalability, okay. Now we jump back to kind of CUBOL and how Spark actually helps on CUBOL, correct? What you have is seamless integration with Jupyter. So we have Spark 3.3 with Jupyter notebooks, and we have an enhanced Jupyter now, which gives you a better experience and productivity. Real-time data explorations in Spark 3.3 is something which is connected to your big data ecospace. You have a lot of when it is connected via Jupyter, you can do all of these AI, ML, machine learning use cases. On top of that, you can have a lot of visual feedback in terms of ad hoc queries, running your dashboards, and you can quickly see more from a visual aspects like creating your charts, reports, and other aspects. And we spoke about this complex queries, and you can run all those complex queries on your Jupyter notebooks. And notebooks are something which will make sure that you can do things much faster and more productive. Now, a quick recap. We spoke about performance breakthroughs, how these Bloom filter joins, adaptive query executions basically speed up by somewhere between 2x and 10x. Yeah, each of them will have a different improvement. So The second is basically the pandas API I spoke about and handling the complex data types. All of them kind of adds up speed, and those are to be observed like 2x faster when you are handling those data in the latest Spark.3.3. And these are a couple of others like error handling, profiling, auto completion are something which are part of the notebook ecosystem, which helps you in your productivity. Now, before I show you a quick demo of how Cuball looks like and the various aspects, one of the things that I spoke about is Jupyter Notebook. I just want to cover a quick architecture quickly. Quickly the architecture of Cuball. And if you see in this architecture, you have got 3 layers per se. Right. So 3 layers. If you see the left side of it, which is more of your data storage and data processing, the middle layer is called as the control plane, where Cuball manages everything for you, and the right side is where you have all your data consumption, basically data consumption, or basically how you can use Cuball. Yeah. So I'll start with the middle part, which is called as the control plane. You can see Cuball. You have got various tools which are available on Cuball, like Explore, Analyze, Notebook, Workspaces. So you have numerous tools. Okay, the reason you have so many tools is, as I said earlier, that Cuball is something which is self-service, and second is basically it is for almost like everybody in the enterprise, correct? So that's the reason you have all these tools, and based on the user skills, they can use the tools which are available. So you have Compose, you have Dashboard, and you have templates. And if you see below, these are the various processing engines. We spoke about Spark 3.3, which is available. Then you have Hadoop, you have Presto, you have Hive, Airflow, and TensorFlow. Compared to other ecosystem, what Cuball provides is the best of the breed. It does provide Apache Spark more from, let's say, ETL and data ad hoc processing, another aspect, but for even faster data warehousing queries or ad hoc queries, we have a better tool, which is Presto, to make sure that you can get responses in a couple of seconds. Yeah. Then you can integrate with third-party ecosystems like TensorFlow for your ML and AI use cases. Then you have Airflow from scheduling, and security and governance are something which are built in, and those are built in at 2 layers. One is on the Cuball control plane, and the second is on the data side, which is managed via Apache Ranger. When you come towards the left side of it, it is basically the Cuball, your data, which is stored in either your data lake, your data warehouse, like let's say a Redshift or any of those data warehouses you might be using. The data ingestion happens from your enterprise data warehouse, which might be on-prem or on the cloud itself. Other applications, streams, IoT data, everything is ingested in your data lake and your data warehouses. And then your data is in your cloud. Your compute is also, the compute also happens on your VPC or your cloud, basically. What Cuball control plane does is just manages all these things. And from a consumption perspective, you have the UI. Basically, I'll just show the UI from where you can log in and do all these queries and write your ETLs and other stuff. You have these APIs which you can integrate in your application, your SDKs, and your ODBC, JDBC. We have native connectors from Tableau. You can connect open source like Apache Superset or any of those tools you should be able to connect. And let's quickly move to a quick demo. I have logged into Cuball already. So if you see us.cuball.com, and we have environment for IN for India and other from a data privacy perspective. Okay, so I quickly jump to the first thing, which is clusters. How do you create a cluster, and in the clusters, I'll talk about Spark 3.3. Let's give it a couple of seconds. Click on New, go to Spark, and use latest. Okay, now if you come here, you can see 3.3, which is 3.3.2 beta. And then you have the other configurations which are to be made. The master node type, what is the instance type that you would be using? What is the worker node type? Do you want to use heterogeneous nodes? Again, these are the various features which helps you save a lot of cost on CUBOL. Then what are the minimum worker nodes and what are the maximum worker nodes? This will help you auto scale based on the data that you are processing, the region and other aspects of AWS. Since I'm showing it this on AWS, availability zone, EBS volume counts, anything that you want to customize, you can do via Node Bootstrap. When you want to kill the cluster, what are the mechanisms? You can run it. You can schedule a job and kill the cluster as soon as the job is completed, or you can have something here, a cluster timeout. I can go to composition. Composition is something which helps you in terms of deciding what are the node types, because as I said, CUBOL helps you save a lot of cost, and how it does is effective usage of Spot instances. Correct? Now it can be done using what type of nodes you are using. Usually the master nodes are on demand. The minimum nodes would be Spot instances. You can use on demand, and then auto scaling nodes can be Spot instances and on demand instances. So this and go to advanced configuration, you will see basically VPC here, which will kind of make sure that your data and processing it confined in your virtual private cloud and doesn't leave that, your subnets, and more from a cloud security perspective. Any cluster overrides that you want, that those are available for use here, and then subsequent yarn and other configurations that you might have. Now, just quickly going into the other menu items, as I spoke about, you have a couple of features or tools available for you, like Explore, Analyze, Workbench, and others, and notebooks. Specifically, we have Zeppelin notebooks and Jupyter notebooks. I will go to the Jupyter notebook. It takes a couple of seconds, come up. Let's wait. And while we are doing this, correct, please share your questions if you have any. I'll be happy to answer them. Now, yeah, from a demo perspective, it's basically how you can use CUBOL, Spark on CUBOL, correct? And these are basically, we created an LLM model on using our Python notebooks, and this is one of them, how you can create. We definitely have a session on that. But this Jupyter notebook where you can, as I said, Jupyter notebooks are something which is used more from data engineering as well as data scientist perspective, so everyone can use it. Okay, so keep your queries coming. So that's a short demo, more talking about how Spark can be used on CUBOL. Since we spoke of most of the things on the presentation, just one more thing that I would like to cover is basically the Workbench, which is again a tool which is used extensively. You can write your queries, Spark SQL. You can write your Spark SQL. You can Scala, Python, or R. Any of them you can write in these notebooks, and this is something which is very effective for a business analyst, let's say, who can write a simple SQL query. And the SQL query can be executed on various engines. As I spoke about, CUBOL does not restrict you to just execute it on one of the engines, that is Spark, but it will allow you to do it on Hive, Spark, or Bistro. Yeah. the same query will be executed on all of them. Okay, so that was it pretty much from the presentation perspective, the performance improvement. I hope you have enjoyed this. Let the queries come in. I'll take a couple of minutes and then answer the queries as and when they come. So one of the queries that has been asked is basically, I was talking about try functions. Yeah, specifically, there's something like there are new functions which are added from try, like try add, try multiply. Yeah, how these are fault tolerant in data processing. Yeah, that was one of the query. So it's a good one. Basically, these functions are designed to handle exceptions gracefully. Yeah, because it's like any other programming language where you have try and catch. Yeah, these are functions, and what these can handle exception gracefully and specifically such as overflow, underflow, or something like a division by zero. These try catches kind of help you in making sure that you don't have those kind of exceptions, and because of which you don't get an error, rather you will get something like a null or zero values based on the exception that you're using. Yeah, that is something that will, as I said, it will help you make sure that it improves the fault tolerance and helps you in making sure that the jobs doesn't fail and you get your data processing done. And one more query. Okay, let me see. How does ANSI interval data types enhancements 3.3, okay, improve the handling of time-based, okay, comparison, correct, to the previous version? I think we covered this, okay, when we said that, okay, the earlier data types, the interval data types, okay, it was more to do with the days of the month. Let's say one day, one month, one day, correct? That comparison was not possible. The reason again was because every month has a different number of days, correct? And then you have to kind of convert it into, let's say, something like an timestamp or cast into some other format and then do the comparisons on arithmetics basically. But with the latest interval, since it is built in, it makes sure that okay, the arithmetic can be, the daytime arithmetics can be executed with the in the latest ANSI interval data type that has been introduced. I hope that helps. And let me see if there are any more queries. Let's give a couple of seconds and now, one more question that I get is basically, are there any built-in functions more from ML perspective, correct? So there are a couple of, okay, which are more like, I think we spoke about that, but yeah, built-in functions like linear regression and statistical analysis functions, which are added in Spark 3.3. Those are two which I can recall, but yeah, there would be lot many which would be available. Okay, thank you everybody. Thanks a lot for your queries, your questions, and thanks for listening to me. Hopefully, if you have any other queries and other stuff, you can just drop an email to help@qball.com and we should be able to respond. Thanks a lot. Thank you. Bye.